Welcome to today's presentation, Creating Platform-Agnostic Packages with Chef Habitat. Package your software once, deploy anywhere. Let's go ahead and get started. Now, take it away.
Hello, everyone. Good morning from here in the Pacific Northwest. It is fantastic to be here with you this morning. I want to just give a quick announcement. I have a bad cold, as you might be able to hear in my voice. So if you hear me coughing, that's why, and I apologize. But I still am up for giving this webinar, and thank you so much for joining us. And with that, let's go ahead and get started. So this is Creating Platform-Agnostic Packages with Habitat. And I'm Nell Shamrell-Harrington. I'm a core maintainer of Habitat. I'm the host of the Adventures in DevOps podcast as well. If you'd like to find me, a good place to find me is on Twitter. Looks like when our slide was rendering, when we uploaded it to this platform, the little Twitter bird decided to fly away. No worries on that, though. But my Twitter handle is @NellShamrell. And what I'm going to cover today is, why is application delivery so hard? What is Chef Habitat all about? How to package and run an application with Chef Habitat and Chef Habitat and containers, and the way you can create a package once and be able to run it both in a traditional bare metal server or virtual machine and in a container. So when I go to tech events or even just log into Twitter, I find a lot of people debating this question. What is the one true way to deploy applications? Some people say you should deploy them in the cloud. Others say you should deploy them in containers, containers always. And when containers comes up, Kubernetes inevitably follows. Now, each of these technologies is certainly appropriate for some applications or some parts of applications, but the only thing I've found in 10 years in this industry is that there is no one way to deploy applications. That one true way does not exist. The best way to deploy applications for me may not be the best way for you. Again, there's no one true way to deploy applications because it depends on the needs of the business for that particular application at that particular time. This is the reality of working in the technology industry as is right now. And furthermore, the best way to deploy an application will change as the application changes and as the business's needs for that application change. This is the one true constant in software. Applications must continue to change and evolve as the business changes and evolves. So what we found at Chef is that what we call multimodal delivery, where you're running some parts of the application in containers, some parts of it in virtual machines, some parts of it in bare metal, this is the new norm. You might even be running certain applications in Microsoft Azure, certain ones in AWS. It's going to depend not just on the needs for the application and the needs for the business, but also on the needs for the team that is creating and running that application. So today's reality is mixed infrastructure. Most applications benefit from running on a set of mixed infrastructure. This involves using containers for stateless parts of the application, virtual machines, virtual machines for persistent data stores, and bare metal machines for static and compute-heavy loads. There are still some things that it makes more technical and economic sense to run it on bare metal. There are things that it makes more technical and economic sense to run on virtual machines, and certainly in containers as well. Today's reality is that a lot of applications benefit from this kind of mixed infrastructure. So if different parts of my application run on different types of infrastructure, does that mean I will need a different way to build and install each part of my application? Well, we've seen a rapid evolution in automation over the past 10 or so years. Now, many of us are likely familiar with the concepts of infrastructure automation. That's been Chef's bread and butter for many years. Now, over the past few years, we've seen there's still a need for infrastructure automation, but we've seen a new focus on container automation with things like Docker Swarm, Kubernetes, and more. Now, there's a third piece in this automation evolution, one we're only just starting to see now, and that is application automation, focusing on the application itself as the unit of automation rather than on what runs or contains the application. Now, there are a few tools out there that do address this kind of automation, but the main one I'm highlighting in this talk is Chef Habitat. Chef Habitat is an open source technology from Chef. Now, before we go further, it's important to understand the why of application automation. Why do we need this when we already have infrastructure and container automation? Why add in another type of automation? Well, the answer to this is actually fairly easy. It's because building and running software is still really painful. You are tied to particular runtimes and environments. You need one runtime for a Ruby application and a different runtime for a Java application. You need different packages for different flavors of Linux, like Yum packages for Red Hat Linux and Deb packages for Debian flavored systems. And you need even more different packages if you want an application to run on both Linux and on Windows. And you need different types of packages for bare metal or virtual machines and containers. Application automation alleviates this pain by building and running modern applications. And when I say a modern application, I mean an application that is immutable, that is agnostic to running environment, and that reduces complexity in automating the application rather than making it more complex, and enables scaling, again, without making the application more complex. Now, this is the goal of application automation and the main purpose of the Habitat project, to help you create these modern applications. Now that we know the why of application automation, let's cover exactly what Habitat is. Briefly, Habitat is a new technology to build, deploy, and manage applications that run in any environment, from traditional data centers to containerized microservices, whatever works best for your business and application needs at that particular time. The reason for this is that in Habitat, the application itself is the unit of automation. That application package we create contains everything needed to deploy, run, and maintain the application in any environment. So again, today we will discuss packaging an application with Habitat, running an application with Habitat, and then containers with Habitat. And let's go ahead and dive in. So when you package an application with Habitat, it first starts here with you, the users. You, the user. This is you at your workstation. It doesn't matter if you're using Windows, Mac, or Linux, Habitat works on all of them. And on your workstation, let's say you have an application, and what you do for that application is you create a plan. This plan contains instructions on how the application should be set up whenever it is deployed. Now, when you're creating a package for a Linux system, you write this plan in Bash. You can also create packages for Windows systems, and you write these plans in PowerShell. Then you use that plan and the compiled application code to create an artifact that contains everything in one place. Now, that artifact is cryptographically signed with a key, and I'll show you how that is used in just a moment. And then you can optionally upload that artifact to a Habitat Depot, which is both a place to store artifacts as well as a place to manage their dependencies. So this is a visual overview of how you package an application with Chef Habitat. And when I mentioned that depot, there is a public depot available. Head on over to bldr.habitat.sh, and you can see all of the packages we currently have available for anyone to use. Additionally, we also now have an on-premises depot available as well. If you want something that runs behind a firewall, we have it covered. You can use either the public depot or the private on-premises depot. All right, I've talked a lot. Enough with the talking. Let's see this in action. And let's look at a demo of creating a Linux package with Habitat. So I'm going to go ahead and share my screen. And there's a slight delay, so I'm going to give it just a moment to pop up. Hang in there with me. All right, hopefully we're almost there. There we are. All right, packaging a basic Node app with Habitat. So here I am. I'm within the application window, and I have here a very simple Node application, Node.js application. And when I package this with Habitat, I'll have a new directory here called the Habitat directory. So this lives directly in my application source code. I can do that, or I can have it separately from my application source code, but for the sake of demo, let's keep it in here. So let's go ahead and look at what's in this Habitat directory. And here I have a Habitat plan file. So this is that plan file that is written in Bash in this case. It's written for Linux systems, though we could write it in PowerShell as well. And let's take a look at exactly what's in that plan file. So let's go ahead and open it up using Visual Studio Code in this case. And here it is. So this is my plan file, and there's a few things in it I'd like to highlight. The first is that I'm defining the dependencies. So I'm going to use a package from the public builder. I could also put it on a private on-premises builder for Node. So this will automatically install everything I need to run Node. I'm depending on that. This is a Node application. I depend on Node being present on the system. And then, let's scroll down a little bit. I define how to build my application using Bash. And in this case, it's really simple. It's a Node application, so we're going to go ahead and just use npm install. And once we do that, let's scroll down a little bit. And along with defining how to build my application, I also define how to install it. And again, this is everything needed to run my application. So that's my JS files into this app path. So this is all I need to do in order to have it running on a live system. Now, once I've defined how I'm going to build this package, now let's go ahead and actually build it and head on into the Hab Studio. So the Hab Studio is what I like to refer to as a clean room. It's a place on your system. It's a containerized studio, effectively, that allows you to build and run your application without having it affect the rest of your workstation. I come from a Ruby development background, and I remember how difficult it was to be developing multiple Ruby applications that use different versions of dependencies all on one workstation. So this allows me to create a clean room where I can install whatever I want to. It won't affect the rest of my workstation. And when I'm ready to build this Habitat package, all I do is go ahead and run build. So let's run that command. And then it's going to install everything that's dependent on it. I did pre-record these demos, and part of the reason I did that was so I could fast forward a bit. This, without the fast forwarding, would take 4 or 5 minutes to build. But let's fast forward just a little bit so we can get to the good stuff. And I see it's generating a package artifact. It is building that package artifact. And here I am. I know my build is complete when I see this message. I love it when a plan.sh comes together. Yes, if it's PowerShell, it will say, I love it when a plan.ps1 comes together. And if I take a look in my results file, or results directory, I see here is my built Habitat artifact. So that's all it took to package this basic Node application with Habitat. Now let's go ahead and exit out of the studio. And let's head on back to the slides. So I'm going to end my screen share. And we'll give it just a moment. Again, there's a bit of a delay. Let's not play it again. All right, and looks like the screen share is ended. Great. And with that, let's go ahead and head on back into the slides. So it's one thing to package an application with Habitat. It's very simple. It's also very simple to run an application with Habitat. So let's talk about how we can run that software. If you have your application artifact on a depot, you can find it on that depot and pull that artifact from the depot onto wherever you want to run it, whether that's a bare metal server, whether that's a virtual machine, or whether that's a container. Now, if you are not using the depot, again, the depot is optional. You could also upload that package you just created onto wherever you want to run it using SCP, FTP, whatever option works best for you. Now you will then run that package as a Habitat service under, under a Habitat supervisor. The supervisor is what manages the application's configuration, updates the package when needed, and more. So there's a few functions of the Habitat supervisor I'd like to discuss. One of the main things it does is it acts as a process manager. This means whenever you pull that Habitat artifact package onto whatever infrastructure you want to run it on, Habitat, the supervisor, will start up and monitor that package. Additionally, it also receives and implements configuration changes. So if you upload a new version of that package to the public depot, say for a security patch, the supervisor will be monitoring that depot and become aware of it, and then pull in that new package, install it, and make whatever configuration changes are needed for it to run. And it also runs services. Now let's take a closer look at what I mean by a service. Under Habitat, a service is one Habitat package running under a Habitat supervisor. And the simplest example is one supervisor running a service on one piece of infrastructure, whether that's a server, a virtual machine, or a container. So this is kind of the visual that I like to look at. So let's say we have a virtual machine running one service under one supervisor. And again, enough with the talking. Let's look at a demo of running a package under the supervisor. So I'm going to go ahead and open that demo and then share my screen. Which, let's go ahead and do that. And I'm going to give it just a few seconds for it to show up because there's a little bit of a delay. There we go. Excellent. All right. So, whoa, I did not mean to fast forward that all the way. Let's go back. All right, so what we are looking at here is we are SSH into an AWS virtual machine. This is a bare bones Ubuntu server. All I've done is spin it up using AWS. This also works for Azure, Google Cloud Provider, or whatever cloud you choose. And when I want to run a Habitat package on this server, first thing I need to do is install Habitat, which I'm doing through a curl command. There's a few other ways to install it as well, but for the sake of this example, let's install it using the curl command. So I go to install it, and this I have not fast forwarded. It pulls the Habitat package, it installs it, and my installation of Habitat is complete. Now, in order for the Habitat supervisor to run, on my machine, I need a HAB group. So let's go ahead and create a group called HAB. And this is Ubuntu, so I use the group add command. And then within that group, I need a HAB user. So let's go ahead and do that using the user add command. And we add it to the HAB group. Great. And now, next thing I need to do is take my Habitat artifact, which I have pre-put on this machine before this demo. I just SCP'd it up there. And I could also pull it from a depot. That would be absolutely fine. But let's go ahead and install this artifact. There we go. And it will prompt me to accept a license for using Chef Habitat. You can also automate accepting this license, and I'll show you how to do that in a later demonstration. Let's go ahead and accept the license for Habitat. And it downloads everything it needs to run it. And again, I did not fast forward it. That was how fast it was to install everything needed to run that application. Then when I'm ready to run the package under the Habitat supervisor, I run the hab sup run command. And it downloads everything it needs, then starts it up. And that is my running application. So let's go ahead and go to the my web browser here. I'm a big fan of the All Things Open conference every year. And let's go ahead and we go to the IP address, the public IP for that virtual machine. We go to port 8000, and there's my running application. So that was real time how fast it is to get a new node application running on a piece of infrastructure using Chef Habitat. Now I'm going to unshare my screen. And let's go ahead and go back to the slides. So once you have the application running somewhere, in the example we just saw, it was on a virtual machine. With the Habitat Supervisor, you can still get information in and out of it using a RESTful API. And this is really useful if you have something like a load balancer that needs to send traffic to that application, run health checks, and more. So I would use my load balancer, I would access this standard API and get the information I need in and out of the application. Now, the real magic of the supervisor comes when you have more than one instance of an application running. So let's say we have 4 virtual machines all running the same packages. The supervisors on each of these virtual machines form a ring. They then use that key that we use to sign the package to decide whether to allow another VM into the ring. Again, this is all the traffic between them is encrypted. They have to all be signed with the same key in order to be able to communicate with each other. And they do this communication over an encrypted gossip protocol, which they can use to keep track of membership, keep track of who's in the ring, who's responding and who's not, and self-organize. Now, along with running Heart packages with Habitat, Habitat also allows you to export your Heart packages into other formats. And by far the most popular format we've seen people export their Habitat packages into is a Docker container image. Now, getting a software package that giving it the ability to run anywhere is very difficult. That's not a new problem. We all know that. And containers were supposed to solve this problem, but there's still a lot of pain with containers in their current state. Part of the pain is that containers can become black boxes. Container images can become black boxes. We don't always know what is in them when we're using them. And it's easy for dependencies to go out of date when they're within that container image that's a black box. There might be a dependency we added to that container image 4 or 6 months ago, and let's say a security vulnerability is found in that dependency and a patch is issued. We may not remember to go back and recreate that container image after updating that dependency. And black boxes, as that example highlights, they cause security issues if a container has something in it with a security flaw, but we don't know or don't remember to update it. Part of the reason for this is that in traditional containers, it's common, particularly when people are just getting started with containers, to start by putting an entire operating system in the container, then adding in the libraries for that operating system, then the libraries required to run an application, and then finally the application itself only at the very end. So this adds a lot of bloat and complexity to containers. Habitat, by contrast, turns the traditional container workflow on its head. You start with the application. Once you have the application, you add in the libraries to run that application, and then only at the very end do you add in a bare minimum operating system that is just enough to run your application and nothing more. So again, when you create a container image with Habitat, Habitat starts with the application, then the bare minimum operating system comes later. We only add in the parts of the operating system that the application needs. When an app has dependencies, when you're using that plan file, the app itself is what's declaring those dependencies and resolving them. That's one of the other powers of application automation. We don't add in those dependencies preemptively. The app will pull in what it needs and only what it needs. And even when a package is within a container, it still has that exposed API we talked about earlier. Other outside services, such as a load balancer, can still interact with the app easily, even though it is in a container. So when you create a container image with Habitat, you know exactly what went into that container and exactly what is configurable about that container. It's not a black box. And again, enough with the talking. Let's look at our final demo and see what it's like to create a container from a Habitat package. So let me just open that up. And then I'm going to share my screen again. Again, we'll wait a few seconds because there's a slight delay. And we'll let that load. There we go. Yay. All right. So here I am. I'm back on my local workstation. I have that sample node app that I created earlier. And when I'm ready to create a container image from this package, all I do is head on back in that Habitat Studio. That's that clean room I talked about earlier. And all I need to do is run hab package export docker. And I export that artifact that I created in the earlier demo. So let's go ahead and run this command. And this one I did speed up just a little bit, but it would usually take maybe 6 or 7 minutes to create this container image. But let's fast forward a little bit so we get to the good stuff. And I've created that Docker image that's been created on my local system. And let's go ahead and exit out of the studio. So I'm back directly on my workstation. And let's start a Docker container from that image that I just created. So we do that using the docker run command. And remember I mentioned you could accept the license programmatically? This is how you do it. You do that by passing an environmental variable. In this case, we're passing it directly to the container. And let's go ahead and finish up adding in what we need to start this container up. And then I give it the image to use. And that was not sped up. Let's go back just a little bit so we can see that again. So this is how fast it is for my container to start up on my local workstation. And let's head on over to localhost port 8000. And there's my running container. So this plus 6 or 7 minutes for creating the container image is how fast it is for me to get that app running in a container and running on my local workstation. So let's go ahead and stop the screen share and exit out of this. So when you deploy a container with Chef Habitat, I mean, it's not going to do much if that container image is just on my workstation. So you can deploy it using cloud-based services like Azure Container Services or Amazon ECS or probably whatever container service you want. You can use container scheduling services, especially Kubernetes. Habitat works very well with Kubernetes. Whoops. And we would love to work with you on however you want to run your container image using Habitat. So as we come to the end of this talk, there's a few things I would like you to take with you. Most of today's applications benefit from mixed infrastructure. Containers buy us a lot, but they don't buy everything just yet. The reality of today is mixed infrastructure. Using Chef Habitat, you can make your applications infrastructure and platform agnostic and be ready to make changes to your application as your application's needs change, as the business's needs change. And you can do that using this platform agnostic packaging. If you are interested in more than application automation or really using the application automation well, you can take a look at the rest of the Chef Enterprise automation stack, but you can also use Habitat in isolation if you prefer. And real world benefits, one of our fantastic community members, Graham Weldon, jumped on really early to help us out with using Habitat to package applications. Rakuten, his employer, is a really interesting company. They've been around since 1997. And since that point, they've made about 30 acquisitions. There were about 30 business acquisitions that they brought on board. Now, when you're bringing in businesses like that, getting everything running on consistent technology and consistent pipelines is really hard. And Habitat very much helped them do that. Again, with Habitat, you create that artifact once, and then you can deploy it using environment, container, VM, bare metal, wherever it is that you need to deploy it. And Rakuten can use it wherever they need to deploy it and manage it using that same way. Now, additional customer that we like to highlight is Alaska Airlines. I am an Alaska Airlines MVP flyer. I love using them, and I love that we support them as a customer. Using Habitat, they're able to build their applications in one consistent way and deploy to multiple data centers as that application is needed. So this helps them maintain that consistency in deployments and reduce downtime with non-disruptive updates. Habitat is what allows Alaska the flexibility to support hybrid environments and multiple application architectures as businesses' needs change and new technologies emerge. And with that, again, I'm Nell Shamrell-Harrington. Fantastic to present to you today, and we're going to go to Q&A. So let me open up the Q&A file.
All right, thanks, Nell. Looks like we definitely have some time for some questions here. So if you have a question, just feel free to put it in the Q&A widget, and we can get those rolling.
I'm going to give it just a minute or two.
All right. We got one here. Ooh, we got a few. Thanks, guys. So the first one here is the basic use of Chef Habitat free?
That's a good question. So Habitat is under Chef's new licenses that we announced back in April, and it depends on your needs. So I would recommend, if you are interested in using Habitat, if you want to know what price it would be or whether you would, where you would fall under that license, please reach out to our sales team. And let's go ahead and go on to the next question.
Yeah, the next one here is, how does Chef Server integrate with Chef Habitat?
Good question. So Chef Habitat, we are working right now, I'm not sure whether it's been released or not, but some integrations with Automate, which would automate together with Habitat. It would allow you to monitor those Habitat packages. As for whether the Chef Server aspect of Automate is directly going to interact with Habitat, I'm not sure on that, but I can find out the answer, and there'll be a blog post posted summing up this webinar, and I'll make sure to include that question in there. So let's go ahead and go on to the next question.
All right, next question here. Are languages other than Bash and PowerShell expected to be supported in Chef Habitat?
Right now, no. I think the plan for right now is to continue focusing on Bash and PowerShell.
All right, great. Next one here. What are the benefits of Chef Habitat over Chef?
Good question. So it's hard to say what benefits of one might be over the other because they really are built for different purposes. Traditional Chef Infra, as we call it right now, is very much focused on infrastructure automation. Habitat is more focused on application automation. Part of what drove the need for Habitat is Chef works fantastic for configuration management. You can use it for application deployment, but it's very painful to do it. And I personally have done that and had a lot of pain with it. So Habitat does work well with Chef as application deployment. You could use it with Chef doing your configuration management, and Habitat doing your application automation. You can also use it in isolation. It really depends on your particular needs. But as for what are the benefits of Habitat over Chef, that's hard to say because they are used for different purposes. But they can be used quite well complementary together for those different purposes.
All right, great. Thanks, Nell. Next one here. At what point should I have a subscription service?
I'm assuming that's referring to a Chef subscription. I would reach out to a salesperson on that. I don't have the answer to that. It's going to depend a lot on your particular situation and your particular needs.
All right, next one here is Chef Habitat geared mainly towards applications with a specific TCP/IP interface, or can graphical or end user applications be deployed as well?
Graphical and end-user applications can absolutely be deployed as well. We deploy the Habitat website, habitat.sh, using Habitat, which is a graphical end-user application. If you'd like to explore that more and tell us what your particular needs are, what your particular concerns are, we're happy to go through that on a one-on-one basis. But yes, Chef Habitat is geared toward being able to deploy any application. So yes, you can. I believe the answer to that question is yes. That graphical or end user applications can be deployed as well.
All right. If there's any more questions, feel free to throw them in the Q&A widget. We have one more here for now. Is there built-in logging to know when a HAB package install fails?
There is. I'm going to have to get back to you on that question. I'm not entirely sure. It depends. I mean, you can use various logging services to know that, but let me make sure I'm getting you the correct answer and an example of it. I will put that in the follow-on blog post.
All right, great. So there's no more questions here. I think we will end it there, give everybody some time back in their day. So just a reminder, the on-demand version of this presentation should be available by tomorrow, and we'll send you an email as soon as it's ready, and you can access it using the same audience link that you're using right now. We do have one more follow-on question here. How do I know that a HAB package on the depot is good quality?
That is an excellent question. That is a question I found on has come up for any sort of community sharing software sharing site that I've ever worked on, which includes Supermarket and a few others. So question on that is if it's in the core origin, you can expect that it's good quality. Those are ones that we are dedicated to keeping up to date, that we are dedicated to keeping building together whenever we do a big update on one of the dependencies of it. As for ones outside of the core origin, we don't currently have anything like quality markers, though we do use those on Chef Supermarket. I could see us using those on the public builder at some point. But the best thing to do if it's outside of the core origin, I think, is to pull it down and test it. If you have some ideas on how we can expose more indicators of how that quality happens, we would love to hear it. And you can do that through our feature request URL, which I don't have on hand right now, but I'll make sure to put that in the blog post.
All right, great. Snuck in a question there, but I think we will end it there. Like Nell mentioned, there's going to be a full blog post coming up after this. So definitely be sure to check that out. Sounds like some of these lingering questions will be answered in more detail on that. So I will end it here. Of course, I have to let you guys know that on Learn Chef Rally, there's a ton of great modules and tracks you can take to get more familiar with Chef Habitat. Among other things, we actually have a fun campaign happening during the month. It's called Our Favorite Things with Learn Chef Rally. Some of our developer relations team have chosen their favorite modules in Learn Chef for you to complete, and you can earn some brand new swag before the end of the month. The new swag is pretty sweet, so I definitely encourage you to check it out, finish some new modules, try some new modules that maybe you haven't tried yet, and you can earn some new swag. So go to chef.io/holidays to learn more about that. And with that, I will close it out. Thanks again, everybody, for attending, and have a wonderful day.
Thank you.